All right, we're back. We're on page 144, and we're going to do a couple more examples of finding the nth roots of a complex number. So we're going to find the cube roots of 4 minus 4 root 3i. Let's see how that goes. So first, we need to know what r is, and we need to know what theta is. So, I look at 4 minus 4 root 3, and I think that's like a unit circle point in disguise. And it would just be 8, and then times 1/2 minus root 3 over 2i. So from there, I know that this is, so I guess I can just keep going. I'll say z is 8 cis, and then what goes with 1/2 negative radical 3 over 2. I'm going to use negative pi over 3. You could also use 5 pi over 3. It doesn't make a difference. It's just like, because I have to add stuff, starting small might be easier. So that's why I'm choosing negative pi over 3. So this is my original number. So I know that r is going to be 8. I know theta is negative pi over 3. I know that n is going to be 3. And since n is 3, k is going to go 0, 1, and 2. Okay, so now what we're going to do is we're going to find z0, which is going to be 8 to the 1/3, which is 2. Cube root of 8 is 2. Cis. So it's theta over n, right? So theta over n is negative pi over 3 divided by 3. So negative pi over 9 plus 2 pi over n, so 2 pi over 3, which I'm going to write, so it's 2 pi over 3, but I'm going to write it as 6 pi over 9. Similar to when we were graphing trig functions, like common denominators make all of your work just significantly easier. Like every time I'm going to have to add 2 pi over 3, I'm going to have to convert it to 6 pi over 9. Now I can just go like straight across the numerators. So this will just be 2 cis negative pi over 9. I don't know what that is, but that's one of the cube roots. Like if I raise that to the 3rd power and expand everything, I will end up with 4 minus 4 root 3i. That's kind of the whole point. So let's find the z1. z1, so that's when k is equal to 1. So it's again 8 to the 1/3 cis negative pi over 9 plus 6 pi over 9 times 1. So that's going to be 2 cis. So it's negative pi over 9 plus 6 pi over 9, which is 5 pi over 9. So every time I'm going to be adding that 6 pi over 9. z2, 8 to the 1/3 cis negative. If I was a little lazier, I'd be copying and pasting these. Sometimes though, it's like I'm not so good at copying and pasting that that it's really the lazy way out. Like I have to like think about how to do it. It's less mental effort to just write it. 2 cis. So I'm adding 6 to the numerator. 11 pi over 9. Now, if I did it correctly, the next angle that I would get, if I kept going, I would add 6 to this, and I would get 17 pi over 9, which is coterminal to negative pi over 9, which means I didn't definitely screw up. Like, it doesn't mean that I got it right, but it means I didn't screw it up. So I don't know the value of any of these. So, like, I can't really expand those into rectangular form. I could check my answer by raising them each to the 3rd power. So let me do that. So let's go in here. Let's see, new problem. I have to define cis again. Cis t going to be equal to cosine of t plus I. So I'm doing this at I thing, but you just use the pi key. Sine of t. Okay, so if I do 22 cis negative pi over 9 to the 3rd. Oh my gosh. Okay, so can I get it to give me an exact value? I don't really know. Well, what's 4 minus 4 square root of 3 at I? Okay, so it's the same. I don't know what the calculator is doing. Some crazy 14 formulas type thing, I guess, maybe, I don't know. But anyway, that one worked, sort of, eventually. I'm going to change it to 5. I'll change it to 11. And that's where I want to stop, because each of those is unique. If I go again, I'm just going to duplicate the first point that I was getting. So I'm going to stop that one there. All right, so let's try another one. Very algorithmic. I mean, like once you know what to do, it's just like a procedure. So let's see. Fifth root. All right. So let's find the 5/5 roots. So k is going 0 to 4. So first, I need to rewrite this as 0 minus 243i. If a problem is nice, like this should be a perfect fifth power. That's if it's nice. If it's not nice, there's nothing you can do about it. But I think it probably is nice. This is just on the negative y-axis, so I'm going to say the angle is, I'm going to use negative pi over 2. Again, because I'm going to add stuff, and so the smaller you start, the smaller like the numbers you end up with are. That's why I'm doing it. N is 5, which means k is going to go 0, 1, 2, 3, 4. So we're writing a lot. All right, so here we go. We'll have z0 is going to be 243 to the 1/5. 243 to the 1/5 has got to be 3, right? 3 to the 4th is 81, and then times 3 is 243. So I'm just going to write 3. And then cis, I'm going to do theta divided by n, so negative pi over 10. And then plus 2 pi divided by n, so 2 pi over 5, which I'm going to write as 4 pi over 10. 4 pi over 10 times, and I'm starting with 0, so like you don't really need that one, but you need it so that the pattern kind of holds all the way through. I got 3 cis negative pi over 10. Z1, 3 cis negative pi over 10 plus 4 pi over 10 times 1, which is going to be 3 cis 3 pi over 10. And then when z equals 2, we get 3 cis negative pi over 10 plus 4 pi over 10 times 2. So 3 cis, we're just adding 4 pi over 10, so it'll be 7 pi over 10. Honestly, you can like just write them down. Like the next one's going to be 3 cis 11 pi over 10, and then 3 cis 15 pi over 10. And you just kind of like have them. So I'm going to actually do that. I'm going to say z3 should be 3 cis. I'm adding 4 to 7 to get 11 pi over 10, and then z4 is going to be 3 cis 15 pi over 10, which is actually 3 pi over 2. So that one actually I could write in rectangular, but like I don't really want to. So if I were going to plot these, which I think would be a little challenging, the thing that's challenging is negative pi over 10. Like what on earth? So let's see. Start with this. We're going to go for it. See if we can do it. Or you know what I could do is I could switch over to GeoGebra. Or you know what I definitely could do is I could just stop this video here. I could check my answers. I can plot them on GeoGebra. And I can do the next problem in the next video. So I think that's the best idea. So why don't I do that? So I'm going to end this here. I will be back to finish this page, and I will see you there.